Okay, so what have we done so far? We've collected a bunch of data, the Skynet telescopes, in the visible part of the spectrum, a whole bunch of images. We've learned how to put them together into nice, clean, deep, hopefully low noise stacks. And then we learned how to group those stacks, put them together in a group, set the order, set the colors, set the blend modes, adjust the brightness and contrast until you eventually end up with an image like this one, where we see the stars in their natural color, but we also see the gas highlighting, in this case, hydrogen pink, and oxygen is kind of the blue or green. And we also have some sulfur in here, which is the deeper red, kind of on the edges. So that's great. But we can do more. The name of this course is Multi-Wavelength Universe, because the lesson is, if we look at the same region of space in different wavebands, there are different lessons to be learned. So what I want to do now is to supplement this image with archival data, data that I didn't collect and Skynet didn't collect. These are collected by other telescopes, other missions, many of them space missions. And I want to do this in the infrared. There are all sorts of great new physics, new things that reveal themselves in the infrared. The visible, you go out to red. Beyond that, you have the near infrared. That's kind of 1 to 2 microns. Beyond that, you have the mid infrared. So in this video, I'm going to show you how to grab mid infrared data from an older NASA spacecraft called WISE. And I'm going to show you how to grab near infrared data from a ground-based mission, all-sky survey, called 2MASS. We actually used some 2MASS data when we did our HR diagram and isochrone matching exercise. Actually, the 2MASS telescope, the Southern Hemisphere 2MASS telescope, is just 10, 20 feet from the Prompt telescopes in Chile. Anyway, the reason we're going to the mid-infrared and the near-infrared is because we can see new things. You look at this image here, and you can see the dusty regions. These are denser clouds in the outskirts, and they're full of dust. That's why they're dark. The dust blocks visible light. Now, this dust, these clouds, they're right next to these hot stars. And these hot stars, we know it heats the gas. That's what's causing these narrowband emission lines. It also heats the dust in these clouds on the boundaries in particular. And it then glows in the mid-infrared. It's nothing we'd ever see in our visible image. It's just dark. But if we go to the mid-infrared, we can find that glowing dust. And we can use that information to study this region physically, which we'll do a little bit later. In the near-infrared, what we can get, you don't see the dust glowing, but you can see the stars that are hidden by the dust in the visible. In the visible here, the light, there are stars in these clouds, but the light is blocked by the dust. But once you get into the near-infrared, you can see through the dust and see those dust-hidden stars. And then again, you go farther out to the mid-infrared, go far enough into the mid-infrared, you don't see the stars anymore, but you see the dust glowing. So those are our goals. Okay. And then there'll be a separate video where I'll show you how to get even better mid-infrared data from a more recent NASA mission called Spitzer. And it's much higher quality, but it's a different website, a little bit trickier to browse through and find what you need, what you want. So we'll do that one separately. This one, we're going to use the WISE data from NASA's WISE spacecraft and data from the ground-based 2MASS survey. So let's go to Skyview Virtual Observatory. So search on Skyview Virtual Observatory and take you here. And we're going to go to the query form. We can see all sorts of data sets here. Everything from gamma rays through radio. And we'll make use of this later on in the course. We'll use some radio data, etc. But right now we're going to focus on, here's our mid-infrared data, the WISE spacecraft, and here's our ground-based data, 2MASS. Okay. This interface is pretty easy to use. Type in your coordinates or the name of your object. Now, if you framed your field up very carefully, you may want to type in coordinates at the center of your frame very specifically. I'm just going to type in the name, and even if it's not perfectly centered on my image, I'm going to grab a piece of the sky that's bigger than my image, so I know that my image is covered. Then I'll crop it once I get the data into Afterglow. So M16, that's the Eagle Nebula. Let's start with the mid-infrared. Well, here in the near-infrared, I said 1 to 2 microns. K-band's about 2 microns. And here with the WISE spacecraft, you can see it picks up at 3.4, 4.6. Those two, it's still pretty much stars. If you want to see the glowing dust, you got to use the longer ones, longer wavelengths, 12 and 22. Let's start with WISE 12 micron. The longer you go in wavelength, the blurrier the images are. Just think about our radio images, how incredibly blurry they are. So 12 micron will be a decent match to our data. Once you get to 22, it's getting a little bit blurry, but we'll just grab it anyway. Let's start with the 12. And then you come down here and you only have 2 more things you need to fill out: the image size and the number of pixels. So for that, I'm going to go to Skynet. The data I collected prompt 6 and prompt 7, but the smaller one, the one that's defining the size of this image, is prompt 6. So I'm going to go there, and its field of view is 15.1. If I know I'm centered perfectly, I could just use that. But I'm going to be cautious. I'm going to go 50% bigger. So 15.1 times 1.5, and the interface wants it in degrees. So I'm dividing by 60, 0.3775 degrees across, 0.3775. Okay. And then the number of pixels, I want to match the same pixel scale as my instrument. So over this 15.1, we had 2048 pixels. So I'm going to take 2048 and multiply it by the same factor, 3072. If I want the same pixel scale, I need 3072. Again, if you used a different telescope, it'd be different numbers. Just go through the same procedure. And then I'm going to submit my request. Takes it a second, but it's grabbing the data, just the chunk of the sky I requested, and here it is. It's really big. There's a little tear in the data set that sometimes happens in the mid-infrared. That's a region that was too bright. We'll have to deal with that. And then just download the FITS file. And it takes a minute or two. While that's cranking, I'm going to change from WISE 12 to WISE 22 and use the same field of view and pixel size and number of pixels. I'm going to submit that one. Here it comes. This is a little bit blurrier, but again, what we're seeing here is hard to see on the scale. It'll be easier once we get in an Afterglow and can zoom out. But this is the dust it's emitting. I'll grab the FITS. I'm going to go back here and I want to switch to K-band to get those dust hidden stars. But the way the interface works, if I'm going to switch to a different collection, I have to clear first, and then I'm going to grab the 2 micron data. I'm going to submit that request. So I'm grabbing 3 images. The Weiss 12 is like 300 micron dust. Sorry, 300 Kelvin dust. Weiss 22 is like 100 Kelvin dust. And then 2-mass, those dust hidden stars. And here they are. Here's the 2-mass data. Stars, stars, stars. Fits. Okay. Now that's downloading. While that's downloading, I'm going to come here and make sure I have some space in my folders here. I'm in my workspace. I'm going to remove some previous Skyview downloads just to make sure I have enough space. And I'm going to upload these 3 images that I just made, that I just grabbed. It may take a moment to get them in there because they're big. We went 50% bigger, so it's about twice as much data, more than twice as much data as one of our images. We're loading 3 of them. It's like loading 6 images in terms of file size. This also depends on how good your wireless is. I'm at home. I'm not sure what my upload speed is, but it should finish pretty soon. There's one. Another. There we go. Got all 3 of them uploaded. So now I'm going to click on them here. Open them up. They're loading in. Grab the whole image there. And as it's coming in, make sure your sync orientation is on in sky mode. Don't sync the displays because we're being very careful about our display settings. We don't want to override it with something simple like this. But make sure these are synced up. That way we can go back and forth. Yeah, so it's certainly bigger than my image. There's that tear that we noticed. See it there? It was just too bright. It saturated the instrument. We're gonna have to do something about that. Show you that in a second. Let's get these other ones in here. So this one here, well, you'll be able to see. You'll be able to tell these are the Weiss data sets, and you'll be able to tell them apart because the 12 micron will be crisper than the 22. And you can definitely see that. Let's rename this. This is Weiss 22. This one here. This was Weiss 12. Which means this should be the 2-mass K-band. I use the same format that we have here. 2-mass K, let's call this Weiss.12.fits. Weiss.22.fits. Now, the next thing we need to do, there's the 2-mass, there's the 12, there's the 22. We need to crop these to match. actually, before we crop, we got to take care of the tear. I don't see any tears in that one. There are no tears in this one, just this one. So there's a command for that. We go to Advanced Pixel Ops. So there's the Pixel Ops, Advanced. And the tear is actually on the bright spot. So it's img.filled, parenthesis, img.max, parenthesis, unparenthesis. So img.filled, and in parentheses, you're right, img.max with a set of parentheses. You're going to overwrite it and submit. Now go through and you'll just fill in that gap. So you just filled it in right now. There we go. Whole thing's filled in. Still, it's going to be ugly, and we're going to have to crop our image to get that out of the way, but it's a good start. Okay, took care of that little cosmetic defect. Now, the aligner. And images to align, we want the Weiss images, the 2-mass image, and any one of these. I got the B band highlighted. They're all aligned already, so I just need one of them. And for my reference, it would be the B. So I'm going to align these new archival images to the B band, and I'm going to have all these enabled, including crop. Align with the WCS, and here we go. This will trim the images down to the size of our image, since our image is smaller. If the images do not overlap, it would then crop our image as well. That's why I was careful to multiply by 1.5 to make sure that these images that I grabbed from the archive were indeed bigger than mine. Okay. And it's reloading it to the right size. Get the micron, the 22 micron in there. Kind of blurry. And the K-band. But it's all the right size. Yeah, definitely lines up. Okay, now we are going to group these. Now here's the thing, when you group, you could mess up the order. That's something I just realized today, and we'll update the code, but you have to reset the order. And so we had 03 and oh, what's going on here? 03 and S2 were right under Loom. H alpha was above Loom. Then we had R, V, B, the bottom. So you're gonna have to reset your order. H alpha Loom, 03, S2, because we put the 03 and the S2 under the Loom. RVB, and then let's slide these to the top. Above H alpha, I put the 12. Above that, I'm putting the 22. Above that, the K band. Let's load the whole thing up. And it's really bright because of the new layers. Let's turn them off for a second. So we can see, here's our image from before. Okay, let's tackle this one layer at a time. Let's turn on the Weiss 22. I'm going to go up here to the display settings. And I'm going to go to the Weiss 22 layer. And this is the warmer dust. And again, you have a lot of freedom here to pick different colors. I like to use the heat and cool maps for the archival data. It seems to work out well, but again, you could try other things. I'm going to use the heat map. There we go. And I'm going to use the screen mode. When you use the heat map with like the lighten blend mode, it doesn't usually work out. Some colors make it through and other colors don't. So let's use the screen blend mode. And we're going to have to switch to midtone. For each of these layers, we're going to have to change the brightness and contrast settings. So midtone, default preset. Okay. Let's check the background layer, the background level. So it's currently at 1. I increased to 10. That's a little bit too high. Let's try 5. Again, you want to be just below the peak a little bit. That's good. Back to the whole thing. And then the midtone, I'm going to bump it all the way up to 99.999, which will essentially turn it off, except for the tear. And I'm going to start backing out the 9s, bringing it up. Okay. And you're seeing that warm dust glowing. It's maybe a little bit too bright. Let me let's try 99.5. Maybe back it down a little bit, 99.75. I'll go with 99.5. Let's try that. So you can see you have your hot stars here, and they're heating the dust right on this surface and right on this surface and these surfaces. It really gives your picture some three-dimensionality. Of course, this tear is terrible, and we'll crop that out when we're done. But it's a nice addition to the image. It really shows where this dark cloud is being heated and where it's not. Okay, let's turn on the slightly cooler dust. Okay, there it is. That's the Micron 22. And again, you can try all sorts of things. I'm going to use the cool color map. And I'm going to switch it to midtone, default preset. Now let's look at that layer to set the background level. Let's try 10. 20 is too high. Let's try 10. Okay, just a little bit below the peak. And I'll come back to the group. And again, I'm going to put that at 99.999 for starters. And this is a much broader diffuse glow. Again, the 22 micron, the resolution is not great. So we don't want this to overwhelm the image. I'm backing out the 9s. There, it's starting to come in right around there. What I used 99.5 for the warm dust, cooler dust, 99.9, let's say, something like that. Looks pretty good. I might actually want to, now that I've added more color here, I feel that I'm losing this, the pillars of creation, it's called. I might want to back down the H alpha a little bit. Bring up the H alpha layer, had it set to 75. Let's try 90. Yeah, see how I dimmed down the H alpha? In fact, most of the color from the optical image is from the oxygen there, and it's being supplemented by the warm dust. So basically, I'm making space. I backed the H alpha down a bit to make some space for the dust, the warm dust colors that I introduced. Now, the cool dust was blue, but when it mixes with the warm dust, you get kind of a purplish color. All right, last bit here. Let's turn on the 2-mass K-band. Stars everywhere, okay? And let's switch to that. And these will be dust-hidden stars. And let's also use the cool color map. You can try different things. I'll use the cool color map for that as well. I'm going to put it in midtone, default. And let's look at just that layer, set the background. Gotta be careful not to, the boxes shift. And so you don't want to change the scale. You want to change the background percentile. Let's try 10, 20, 30. I'll do 20. Okay. Come back here. And I'm going to crank this up to 99.999. Turn it off. There we go. Start backing out the nines and bring up these cool stars. See them popping in there? You want to be careful not to overdo them. If I go out to 99, yeah, that's way too much. 99.5. Still feels like a lot. 0.75, 99.75. Maybe. Let's take a quick peek. So I'm rotating it around. And I'm going to flip it. This is the correct orientation on the sky. I'm going to crop out that region where the Weiss just kind of saturated the detector. That feels like a lot of blue stars, more than I was hoping for. I'm hoping for just kind of a sprinkle of dust hidden stars to make it a little bit more interesting. So 99.9, let's say. Okay, let's grab this again. Rotate. Opening up the controls. Flip. Trim. And that's pretty cool, I think. So hot stars, they're heating this gas, ionizing it. You see a lot of oxygen, which responds better at higher temperatures. Out here, you start to see the H alpha and the sulfur 2. Once ionized sulfur, they glow at lower temperatures. And then you're up against the cloud front. And the first layer is has dust in there. I mean, there's dust everywhere, but the first layer of dust is getting heated, and you see the really warm dust on the star-facing surfaces. Here's one here facing the stars, and also some cooler dust up in here in particular. And here's a little globule of cool dust. Okay, so I'm going to save that. That's pretty cool. And in the next video, we'll learn how to grab Spitzer data and replace the Weiss data. It's higher resolution. All right, we'll stop there.